Alright, in today's video we're going to be learning about how to make free body diagrams. And if you don't know what a free body diagram is, it's basically just like a diagram that shows all the forces acting on an object or like a system of objects. And let's see. So, if we go over here, let's just like give ourselves an example. Let's say that there's just a book sitting on a table and we want to identify like what forces are acting on it through a free body diagram. So typically you're just going to draw a dot for the object or like the system for your free body diagram, and then you draw like arrows off of the free body diagram to like in the direction of the force. So if you think about it, there's only really two forces acting on the book if it's just at rest on the table, right? So there's going to be, gravitational force, which we will denote with F subscript G, and there's going to be a normal force, which we denote with F subscript N. And then let's say that you are pushing the book like straight across towards the right. Then we're going to have an applied force in this direction. And then that's assuming that it's frictionless. But if it did have friction, which we will go over in a later video, then that friction will be pointing in the opposite direction of the motion. And there we go. That's our free body diagram. And then it's a bit different regarding inclined planes. Let's say that this table had like a 30-degree incline. Then we would be drawing like a slightly different diagram. And we'll go more into like inclined stuff in a later video, probably through like an example or something like that. But going back to our example, and I did not leave enough space for myself, but whatever. So gravitational force would still be acting downwards. But now that there's it's probably not a good place to draw that. Let's say that this was like our representation of that book on the table. Well, the normal force is going to be acting this way now. Oops. So we're going to have to draw it like that. And then our applied force, let's say we're pushing it upwards, it's going to be along this line. And then our friction force will be just acting in the opposite direction of that. And I did not label that, hang on. And if you watch like the vector video, we'll know about, flipping, we'll know about like rotating the axis in order to calculate this. But if you want to know more about inclined planes, then go watch the video for that. Alright, so for the AP, they have some regulations on free body diagrams. So let me just go over them really quick. So first off, your arrow has to be like touching the little circle that's representing the object. Like if it was like that, then it doesn't count. Alright, they just don't count it. Also can't make it just come out of the side like that. It has to, like, if you want to draw two forces acting on an object, it has to look like that. Like, they will take points off if you draw it, like, coming out of, like, the object, like, in the curve. I mean, I don't know why, but that's just the way it is, alright? And, for certain types of problems, you have to be, like, wary about, like, the magnitude of your force. Since, like, sometimes it's going to be obvious that, like, one force will be significantly shorter than the other, or like another force is significantly longer than the other. It just depends on the context. And that's about it for free body diagrams.